Okay, in today's tutorial I will be talking about the cam, but the cam that I would like to talk about is like this cam, which is in the I would like to solve this problem, how to create the drawing of the cam and then create the 3D model. As you can see, cam is two parts which consists of follower, and then this cam itself, when it rotates, they will lift the follower up, and then they will follow the path here, and then they will going down again, as the curve here explain about 0 is the 0 point, 0 degree, and then it will rotate, they will rise until the 60 degrees, and then they will dwell. It means there's no lifting or lift or drop basically, and then they will drop again in the angle of 180 until 300, and then they will dwell again until to the position. So it's as the explained here, this is the 60 degrees of rise here, and then this is the 120 degrees of 120, and then also 120 degrees of fall, and then dwell again at 60 degrees. Usually I create this cam using the Inventor. In Inventor there is a feature here that we can create, we call it design accelerator. We can create a cam easily. We just put the parameter here, how much the degree and position, how much is the lifting height, and also we can select from this shape here of the motion function that we like to create. So if you like to have a linear mode, and also like say that's parabolic with the second degree of polynomial, and also we can see the speed, the acceleration itself. Look, there's an acceleration, so this one there's a smooth acceleration, deceleration. Since the fusion, they don't have any of this feature, so we like to create it manually. So let's get started. I like to use the top view as my first of all. We have to create the base circle. So in this case I will create a 100 millimeter for the diameter of the base circle, and then in here I like to create the line. So this line is basically have the line which is the pi multiplied by the diameter here. Okay, so this line is basically the basic circumference of this circle. Okay, and then for the lifting, so we have to set how much the lift. In this case I will do maybe 50 millimeter for the lift. So the lifting is basically this one, lifting how much height that cam will lift. I don't follow this value here, I just create by myself, so I decided to use the 50. And then we have to divide with the line to divide a section here. Okay, so basically if I create a dimension here, so they will 60 by 350, 360 multiplied by the length of the circumference. So this is the 60 degree, and from here to here 180 by 360 and times with this. So this is the 180 degree, and then I create another one. Okay, and then this one is the last one. Okay, so this all basically just the reference. So I create the construction line. Okay, from here to here is supposed to be 300 by 16 and multiply by the so this one is the 60 degree, 180 and 300 and 360. Okay, and I also want to create a center point arc from the midpoint here, okay, to here. Okay, and then I divide, okay, here, 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 and here, and make sure this is the 30 degrees. Here also 30 degrees. Here also 30 degrees, and all I divided to the 30 degrees, and here also the 30 degrees. Okay, and then the length here I have to make the same length of here, because this is our reference for the lifting. Okay, and then in here is a dual, so I create a line first, and then that one is also a dual. Okay, and we want to make this curve here. Okay, okay, let me use I also want to make a section from here, so this basically I like to divide into 6, so I will use the rectangular pattern. So this is the 7, okay, and then we'll measure this from here to here. Okay, and the number continues, say 7, 1, 2, 3, 4, 5, 6. Okay, 6 segments, and then create a line here. 1, 2, 3, 4, 5, and then there's the last one. So I create a spline. 1, 2, 3, 4, 5, 6, 7. So this is basically the spline which is representing this harmonic rise. Okay, and then I will do the gain from for here rectangular pattern. This is the number quantity is 7 as well, and then I will measure the from here to here. Why didn't cannot measure? Here, measure. Okay, measure. From here to here. Okay. So 1, 2, 3, 4, 5, 6. Okay, 6 segments. And then also create a line to extend. So I don't need to do. I just follow the path here. Okay. So from here to here, and then this is the third one. Okay. This is the fourth. Okay. This is the fifth. Okay. This is the sixth segment. Oh, I lost. Yeah. Maybe this one I have to be carefully here. Okay. So it's done for the harmonic from here to here. Now how we can transfer to here? So basically if I reference this one as a 0 point, so I will divide first with the line here. Okay, and then I draw, maybe I don't need to draw right now. So this is I create construction, and then I create the 60 degree. Okay, so it's a 30. Okay, so basically this one is if I measure, this is 60 degrees. Okay, create the construction line. Already construction. Okay, so this is from here to here. Okay, this is the 180. So I would like to create this one, the 12. So I use the center point up here, and then because the length is 50, so I need to add another 50, so 150. Okay. Oh no, 50. Yeah, 150. Or maybe it's to get bigger, because the dual is 50. Yeah. We have to offset this 50. Okay, so this is the 12, and then we extend this one. Extend. Okay, here. Okay, extend here. Okay. Okay. Here. So basically from here is 60 degrees until here 180 is a dual. This is the line, and we want to create this kind of line for the lifting. So as we divide here by 6, so we also have to divide this particular line. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, 6. And then make the angle 60 by 6xy. Okay. Good. This one is also the same. Okay. Should be 10. Okay. Okay. So, this one should be over there. Oh no, there's a 2 line here. Mistake. Okay. Here, 6. Here, and 10. Okay. And then we measure from here to here is the first lifting. So from here we measure for the first lifting here. Okay. So I usually use the point to make my measurement become accurate. So from this point to the center, make sure that you have the align, and then I measure from this point to this point, and then I added the 50 for the radius. Okay, from here to this line is 50, and then this is the lifting. And also make a measurement again, measure from here to here plus 50. Okay, and then measure again from here, measure from here to here, and then plus 50. And we repeat again there, measure from here to here plus 50. And also this is the last one, measure from here to here plus 50. Okay, so this is the dot, and then we just connect from here to here, here. Okay, so this is the shape. If we look at here, okay, so this is the shape of the cam, and then we continue with the drop area. This is the lift area, and we continue drop area from this one until maybe roughly over there, and then because this is the 300 degree, so basically it's 60 degree from 0. I make the, okay, this one is 60. Okay, so this is a 300 degree from here, 0, 300 degree. So from 180 to 300 degree. So basically we have to divide this by 6 as well. 1, 2, 3, 4, 1, 2, 3, 4, 5. Here add another one. So we just create the measurement 120 by 6. Okay, here to here, same. Here to here, it's the same here. Okay, this one is same here. Here and here is the same. 1, 2, 3, 4, 5, 6. So okay, wait. This one I should another. Okay, here and here. Why this one cannot? 1, 2, 3, 4, 5. Why? Okay. Okay, let me add this one. Okay. From here to here is 20, and from here to here is 20. Okay, let me check here to here. It's supposed to be 60. Okay, yeah, okay. And then from top until, so in order to not to make a confusing, I will change to the, so this is the segment, is the drop from 180 degree to 300. This is 180, this is 300, so they will drop from here to over there. Okay, and then again I will create a point from here, 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 okay, until there. Okay, and then again I will use the measurement from here to center. Okay, so it's basically same, like same method. I will measure this one and then plus 50. Okay, and then measure this one from here to here. Use measurement. This first from here to here, and then plus 50. Sorry, 50. Okay, from here to here, measure from here to here, plus 50. Okay, then from here to here. Okay, measure from here to here, plus 50. Okay, and then this is the last one. Measure from here to here, plus 50. Okay, so we just finish up with the fit spline. 3, 4, 5, 6, 7, and 8. Okay. Okay, so this one is basically the shape. If we finish the sketch and then we do the extrusion. Okay, I should use the construction line. Maybe I use the, okay, 25 I think. Oh, sorry. Yeah, I left this one. Okay, so this is basically the shape of the cam that we have created. Okay, so I have the same shape, and also if we compare with the Inventor, so in Inventor is depend on the Harmonic, this one and this one also Harmonic. Okay, this is the Harmonic shape, so it's also almost the same. Maybe it's because of the size is not the same. I create this one with this one. So this one is basically has the same shape between those two from here, and then with this follower and motion. Okay. Or if you like to add another feature, maybe the shaft here, then you can add many of the feature, or maybe just the chamfer from here to add the chamfer. Okay, you just add it as many as you like. But that's it for today tutorial that I already show you how to create this cam. Okay, and don't forget to subscribe and give a thumbs up, and bye bye.